Okay, guys, I'm going to save this here. If a couple of people ask me, this problem is going to be here. Okay.
Progress.
Anybody has any questions for me, guys? Okay. So, guys, we're going to work on some of these. Okay. Remember, guys, we talked about odd and even properties. Okay. I'm going to review it a little bit, just a little bit. Okay. We discussed it last class, but it's worth repeating. Okay. Odd and even property simply means, remember, guys, X is cosine and Y is sine. Let's write it down somewhere. Sine theta is the Y coordinate, and cosine theta is the X coordinate. All right. Now, if you go like this, I need something this big. All right. So if you go like this, theta is positive. If you go like this, the opposite way, the same angle, theta is going to be negative. Okay. That tells me that cosine theta, the x coordinate, is going to be the same whether theta is positive or negative. Okay. So this is unique to cosine theta and cosine's reciprocal. Cosine theta is equal to cosine negative theta. Okay. And cosine's buddy is, they're going to be the same because they're x coordinates. Okay. And you can say the same thing about something in the third quadrant and the second quadrant. The exact same argument works. And cosine's buddy is going to be secant. It's true for them, that one too, because they behave the same way in this context. Now, what happens to sine, guys? When you say sine theta, sine is the y coordinate, that's going to be plus. And for minus theta, sine is going to be minus. So for sine, the formula turns out to be this. Sine minus theta is equal to minus sine theta. All right. This is called odd and even property, and you can say the same thing for sine and cosecant are behaving the same. They behave the same way. So what did we learn? If you have a minus sign for cosine and secant, you can pretty much ignore it. It's just a nuisance. Get rid of it. For sine and cosecant, they're going to come out. Now, the way the tangent works, if you define tangent as sine over cosine, cotangent sine over cosine over sine, tangent works like this. And yesterday, we kind of proved it that it does. I don't want to prove it now, but it's going to be the same. And I am going to say the same thing for cotangent. So it's a little bit of a review. You have all the these are called odd and even properties. They're here. Now, let me grab my odd and even property from here. I have a slide here that'll save us a little bit of time. Right here. Okay. So we're going to use odd and even property. And again, you want to make sure you have access to this. It would be nice to know for cosine and secant, you just ignore the negative value. For everything else, it comes out. So here it is. Let's try a couple of problems, all right? So it's really not that bad. Let's see what they're saying. Use the odd and even property, find the exact value. Do not use your calculator, okay? So let's find this. Let's do cosecant negative, number 64. We'll do a couple from here. All right. So cosecant 30 degrees, negative 30 degrees, Cosecant, I can pull the negative sign out. I can say, all right. Now, to find cosecant 30 degrees, I have to know cosecant's reciprocal is sine. All right. So I have to know sine 30. If I know sine 30, I'll know cosecant 30. But sine 30 is easy. It's something we learned in 2.2 and you took your exam. How do we find sine 30? I'm gonna do it in exact way. So sine 30, remember guys, sine 30 degrees is going to be here. It's pi over 6. Okay? Pi over 6. And remember the triangle, this line, if this is 30 degrees, this is 60 degrees, this is going to be, these are my coordinates. Now you might say you're just going to punch it in your calculator and be my guest, okay? But if you don't understand this, if you don't conceptually understand what I'm doing, you will have a lot of difficulty with other things that we will do in future real soon. So be aware of that. And I won't give you a whole lot of problems that you can just punch in your calculator. I'm very aware of that. You guys have access to calculators. So just be a little um, cognizant of that. I have to do it very carefully. This line here is from that triangle we discussed, is square root of 3 over 2. And this line here is half. So y is half, x is 2. That sounds about right. This point right here. So that tells me sine theta is the y coordinate. That is half. But I don't want sine theta. I want cosecant theta. Cosecant theta is going to be 2. But don't forget the minus sign. The answer is -2. Okay? And I'm going to check my answer real quick. 64. Let's see what they're getting. -2. They got -2. So we are okay. Again, I'm repeating myself. I'm not going to give you a bunch of these that you can just plug in your calculator. I won't, but there will be some problems. Well, they'll kind of say, explain where this is coming from. There are some problems like that in 2.3. So make sure you kind of understand that this is the building block of trig. If you don't get how I calculated it, you're going to really, really struggle. I'm just giving you a heads up. That's all. Let's pause there a little bit. Now you can keep your unit circle handy. I don't see a problem. I have a unit circle here. I'll show you. This one came from your book. I think I just grabbed it from your book, if I'm not totally mistaken. You can print it, you can keep it handy. So basically, I'm going for this, but I will not directly use it today. I will do it from scratch because you should know how to get it from scratch. But later, I'm just going to put it on my screen and work on it. All right. Let's see what else is going on. It's very similar. And you can do some, you can ask me to do some later. Let's see what else is going on. All right. So remember, guys, we talked about periods. These are about periods. What does that mean? Well, we said that adding 180 to the let me go back to that slide, okay? It'll come back. Let me go back to the old slide that we used yesterday. 2.3. This is from section 2.3, and these are called periodic functions. And this is the odd even property we talked about today. All right, so here. So the period for sine, cosine, secant, and cosecant is 2 pi. That means if you add 2 pi to an angle, your value won't change. If you subtract 2 pi from an angle for these four, your value won't change. The period for tan and cotangent is pi. After pi, tan and cotangent repeat. Now, it's a little hard to see for you right now. We're going to graph it later in chapter 3. It will make sense. You're going to see after every pi, tan curve, the curve for tan is exactly the same. So right now you're going to use this to understand or use to answer those questions. So let me grab this and keep it handy over here, right here. Let's do a couple of problems from your book. So this one is actually not difficult at all. I'm going to do an easy one first, then I'm going to do a hard one. I'm going to do a couple actually. So let's do an easy one. 82. This one, I don't have to check the, well, I will check the answers, but they're so straightforward. So cosine 20 over sine 20 is cotangent 20. Okay, that's how it's defined. So I'm going to write is equal to cot 20 minus cot 20. Why am I writing cot 20 second time around? Well, cosine 20 over sine 20 is cot 20. Cot 20 minus cot 20. I don't have to know what cot 20 is. I don't need my calculator. The answer is 0. And this is 82. I really don't have to check it, but since I have it, I'm going to check it. 82 should be 0 right here, okay? So we're okay. So it's really not that bad, okay? I haven't used the periodic function yet. I think there will be some, I'm hoping. It's from this section, so that's that. Let's try 78, okay? This to me, whenever you see a square, it looks like we can use the trig identities, okay? We'll use the trig identities. So this one you can just do it in your head. Sine square x plus cosine square x is 1. So 77 is 1. It's really that simple. But I'm going to not worry about 77. I'm going to do 78. How do we handle something like 78? Okay, let me grab the trig identities that I saved. All right, here. Now, to me, this resembles the second one. Okay, now if you move the tan square theta here, wouldn't you get minus tan squared theta? Here, theta or x, doesn't matter, it's both 18. Okay? So if you move this here, your 1 will be left over, so this has to be 1. So that's 1. Done. You just have to move in the previous problem, 77, it was sine squared theta plus cosine squared theta. That you could almost do in your head. But now it's secant squared theta minus tan squared theta. Well, move tan squared theta here. That's going to be minus and 1 will be left, so that's 1. I'm going to pause there for 1 minute or so. See if you guys see what I'm saying. Okay, let me do, I will do something with pi, okay? But let me do this first. I'm trying to do some of the easier ones first. So, and I will use the properties. These are called periodic properties. I will use them. I already saw a couple of problems, but actually this is one of those. Remember, guys, the period for tan is pi. Pi is 180, and that simply means instead of 200, you can write 200 minus 180. That's legit because tan values repeat after 180. So I'm going to write tan. I'm not going to write 200. Instead of 200, I'm going to write 200, 180 degrees plus 20 degrees. And you're going to see why that's not a bad choice. And don't forget your cot 20. Okay? Now, remember this formula? This formula tells me if you have a pi or 180, you can pretty much ignore it. That's going to be tan theta. All right? So I will actually put it here if you want, if you don't mind, because I need the room. Now, I can write this can be written as tan 20 times cotangent 20. Why? Because of the periodic property. Now, tan and cotangent are reciprocals of each other. Okay, what does that mean? They will cancel and the answer will be 1. Take a look. If 2/3 is 1, the other one will be 3/2, and they will cancel, and you'll always be left with 1. When you multiply two reciprocals, the answer is always 1. So the answer to this is 1. Okay? That's 84. I'm going to pause there a little bit. I don't think these are that bad, not as bad as the first chunk that we did, but now we are going to do one that you will find it a little difficult. Why? Because it involves pi. I was trying to avoid the ones with pi because they involve fractions, but now I think we're ready, but I'm going to pause there just a little bit, guys, okay? I didn't check this answer. I'm pretty confident I'm right, okay? All right, guys, let's grab one and do this one slowly. And you will see this is all about fractions, all about fractions. And your calculators are not going to totally help you. Because if you don't see the fractions, you won't be able to just punch your way to the solution. You won't be able to. All right. So I'm going to see what I can do here. This is one of the harder ones, right? Okay. So guys, whenever I see this fraction is clearly, I'm going to find 37/18, okay? I'm going to do a little division for you here on the side. 37 divided by 18. 2 times 18 is 36. And there is 1 left over. So this fractions, I'm going to write it down on the side, and you want to see it. And ideally, you want to see it without doing it, doing the division. 37, this is the claim I'm making, is 2 and 1/18. 1/18. Okay. Now I have a pi here. I have a pi here. Let's put that pi here. So this is a little extra work that you kind of want to actually see it. And this is going to be 2 pi plus pi over 18. It's the same thing, guys. Okay. 37 is 2 whole pi and 1/18 of a pi. And that's good news, because instead of 37 pi, I can actually write this. I don't think I need this. I can save it here in case you ask me how it was done. I'm going to go here and rewrite this very patiently. Secant pi over 18 minus, now instead of cosine 37 pi over 18, I'm going to write pi over 18 plus 2 pi. Guess what? 2 pi is the period, right? And when you have that thing inside, you can pretty much ignore it right here. If this is 2 pi, it's going to repeat. You can ignore it. You can just write cosine theta. So having said that, I am going to rewrite this as, I'm going to say, well, that's easy. I don't need this mess. I don't need the 2 pi extra 2 pi. And another piece of good news. All right, so secant is cosine. So I can ignore the minus sign. Remember, odd and even property, secant and cosine, you can ignore this minus sign. So I'm going to now go ahead and ignore it. What do I see here? Secant of pi over 18, cosine of pi over 18, secant and cosine are reciprocals, okay? Reciprocals, and you're going to write 1. Now, I'm going to tell you, many of you, I'm not talking about you guys in the past, students would make a mistake and they'll write a -1. You enter -1 on your on MATLAB, and you're gonna get it wrong. So the answer is 1, and I'm gonna double check because I may have messed up because I'm talking. 86, 1. 1 is the answer. So we got it right. So that's a lot of hard problems we did today, guys. Maybe you have to watch the video a couple of times, but I'll be happy to take some questions from you guys. See if you want me to do something. You can always go do your MATLAB. When you do your MATLAB, you can always ask me to do something. The problems that are on MATLAB are very similar to the ones I did. So for me, this kind of concludes chapter 2.3. That doesn't mean you can ask me questions from 2.3. You can always ask me questions. I'll be happy to do it. We can even kind of go back and say, can you do something from 2.2? I was working on it. I couldn't do it. I'll be happy to do it. Okay, guys, so I'm going to jump out of this session. I'm going to come back. We still have 30 minutes. I'm not going to start a new section. Feel free to join me if you have any questions. Otherwise, I'll call it a day. But I will return and I will probably not record. All right. Thank you, guys.